use that when we plan as well. To get the kids engaged in this and get them to explore a little bit more. And what are the ways we can extend it further for them? And so what we did was we had them explore energy, specifically some electricity for different materials. And then we said, well, how can you manipulate it? How can you use it? So we use a variety of modern programming tools, the Hummingbird robotics kit, the Makey. We just installed a little circuitry, and so kids were doing a whole slew of projects. We had about 200 students and about 85 different projects this past fall that they did. And it was a great experience for our teachers because they saw how I was interacting with the children when I was in their classroom, or we designed something in the lab for them, and how you work through a child's debugging of something. And that culminates in the Maker Showcase where kids show off their, and they share. So they have that bridge to certain things, and the parents all come in, and it was just a really great experience for them. So what's happening right now is I'm actually moving on to the middle school because you can see a need up there and it sees an opportunity to do that. So there's been a large interest in the school-wide level. They don't know exactly how to define this yet, but we took a trip to California to do some research on that and see some schools that are doing wonderful things in the States. So we really raised an awareness. It wasn't just us, but there's more talk of it, more support from parents. They're asking for it. Where is it? Why isn't it in the middle school? And that's probably why I'm going up there. But we've also found that there's more interest in programming in all divisions. Our lower primaries using the BMOS and Scratch Junior and all these other some programming environments for the younger kids. And we're having that conversation about how we do this pre-K through 12. So that's a little bit where we're at now.
So our next speaker, Amy Dugré, was a nursery grade and graduate student of mine, and even more horrifying, I now share her office at the Willows Community School in a suburb of Los Angeles. And Amy is the tech director for an independent school of about 450 kids from preschool to 8th grade, and she focuses a lot less on the nuts and bolts of keeping the hardware working and a lot more on vision, professional learning, curriculum development, and building opportunities for kids that wouldn't exist without computationally rich, creative, interesting. So over to Amy.
Thank you. Our tech failure. We're very good at tech, all three of us. Well, all right, so let me tell you a little bit about the Willows. Our goal at the school is really to keep everything that we're doing. Not a last word, sorry about that. Our goal at the Willows and my job is to bring as much of this tech, the idea of a constructivist approach to learning, into our technology and into our school community as a whole. So while my title is technology and there's lots of tech up there, it is not limited to that. We want it to be embedded in everything that our kids are doing all the way through the school. So our school is considered a progressive school. It's kindergarten and pre-K through 8th grade. And we begin with our very youngest learners, making sure that they have opportunities to learn to express themselves, to construct knowledge, to learn by doing things. We want them to have lots of hands-on experiences. And so we utilize the tools that are of interest to them, that have high engagement for them, and working very hard to make sure that they're the ones choosing and taking some agency and helping them to choose. We guide them. We certainly have to be part of it, right? With scaffolding and making sure that they have work to do, that we can take them to a higher level. We work with VBOT, Creative Beto. All of it is programming based, wanting them to think, as we've been hearing throughout this conference, in logical ways so that they can build their understandings more effectively, more efficiently, and in a better way. So we work it into making. We've been a major part of the Maker movement. I love that there is now a movement for us called Maker. I think we've been doing it since probably 1998, which is even still a baby step. We work with every grade level and every teacher. So we no longer have tech classes that they come out to. It's part of our classroom experience across the school. We have laptops in classrooms. We want them to use laptops, not iPads or other tools. Not that they can't use the iPads, we have them available. But we like the idea of the construction that you can do with a computer, not so much the consumption. That's still really good. So we teach skills through real content, and we work very hard to engage our students, again, in ways that are meaningful to them. The slides are so bad. So these images here that we're looking at, these are children who have decided what it is that they wanted to explore more. So we're utilizing Makey. We've got hummingbirds that they're working with using Snap to program it. The children physically built environments. So the top one is actually a video which I won't play, but they've got a hippo eating piranhas that are trying to catch a bird, and they've created motors and it's spinning. Can I play it from here? That's all I got. And this is a group of third grade children, the boys that are up here to the left. And they just decided they wanted to make a circle of life. They wanted to demonstrate what they understood inside in their classroom, making sure that as they were learning about environments, habitats, this was the way that they wanted to express it. They used programming, they physically built things, and they used motors and gears to get everything going. This is high interest, high gain. So this is actually a classroom experience. Gary came in, but the computers are used in their classroom, not as a separate subject, not as something that they come down the hall to learn. Scratch, turtle art, micro-world, we do all of these things within our classroom experiences. So one of my responsibilities is to work both with the classrooms themselves, but also the teachers, to make sure that they have the skills to continue to move this forward within their classrooms. So this is a regular class time. We were exploring mathematical concepts, the idea of repeating. This is in some turtle art that they were doing. So Ben started working and he figured out how to write his name with a very long script. And then Gary came along and challenged him to try to add yet another iteration to it. And the kids work in incredible ways to get much deeper in their thinking, and the teachers are engaged. So I've got about 80 computer teachers on my campus because they're not regular classroom teachers. So our successes and opportunities, right? Our goals are always from the youngest to the oldest. We're trying to make sure that everyone has an opportunity. We are trying to make sure that everyone is learning and engaged right alongside our kids. It's not just me. I don't want to be the only teacher working on this. It makes it much too person-dependent. And there's too many children and too many teachers to not enlist them in a way that is totally useful. Creating a culture that embraces constructivism. That's not so easy. There's so much focus on literacy, and we'll talk to you about the challenges in general, because it isn't all easy. But we work very hard to make sure that our teachers understand why we're doing this. Why is this a better way to learn? Why is this a better way to apply ourselves and all of our energy? We also do family maker events. We work very hard. They're not allowed to say they're not coming. Parents have to come. We want them to be engaged. We want them to be part of that process. We have our children teach the parents the types of things they're doing in school, and they work together to show their parents what's happening, to explain what they did, what their process was, all of that. So when the kids made the hippo, the parents come through, they talk about it, they explain what their thinking was, what their process was, how they came about both the idea and then their final outcome. So I didn't widen a little bit here too. So these are my DK kids. They're 4 years old, 4 to 5. And they're explaining to us what they did with little bits. More silly. So what I've explained to us is experience with little bits. The kids take their little bits or any other experience they have and apply it to something else. So we've got Ava down here in the corner who decided she was making Tinkerbell. And so she did a very elaborate drawing and she lit up Tinkerbell from behind. And then she put on a sensor so that when you came by, Tinkerbell lit up. And it was a sound sensor, so if you clapped, Tinkerbell would light up. And these are my 4-year-olds. And they understood both that concept of input. They've got a sound that triggers something else, an action. They apply the action and share that with us. These are my challenges, and they're a little bit different because I think if I'm in an independent school, Brian's at the international school, Tracy's at a public school. We all have some of the same challenges as we go, but not all of them. For me, it's time with children. That's a hard one, but it's because of the push of so much else, so much other curriculum, right? There's curriculum we have to do. We need to teach math, we need to teach literacy, we need to teach writing. How do we make sure that we work these things in? So it's my job to make sure that the teachers have time for children working on these skills and these applications that we're talking about in a constructivist way. The talent, more specifically even confidence and skill level of our teachers, it's a really big deal. They are not all constructivist educators, they're not programmers or computer scientists, they don't feel comfortable necessarily teaching programming as an example, and it's my job to help them see they don't have to know it in the same way, but they have to have some skill with it. So we've got to bring them along with us and make sure that that's part of their experience.
So I'm told that I have to stay behind as the only voice who can constrained by that. But, so I'm going to sacrifice what I was going to say. So I want to introduce Tracy. I want her to tell her story. Tracy's a public school teacher in New York City. 7 years ago, she arrived at my Summer Institute of Constructing Modern Knowledge. And when introducing herself, said, I work in the school, I'm the only one who uses computers, no one listens to me, no one pays any attention. I'm trying to do good things, I'm not getting any support. And I said, where are you from? She said, New York City. And I said, I don't know all the schools in New York City, but I know a few. What's the school? And the answer would horrify anyone who's unfamiliar with school politics, but none of us, which was, she teaches at a place called the computer school. And what makes matters worse is the computer school was started by Seymour Papert and Carol Sperry. And if you've read the Computers Material Messing About with Time article, it happened in her school. A couple of years ago, Tracy fundraised to buy 2 plastic tables so that during lunch, her classroom could be transformed into a makerspace. She will not suffer from the tranquilizing drug of gradualism, as Martin Luther King said. She was named last year as one of the 20 educators to watch in the United States. She's involved in writing curriculum for the rest of the city of New York, and it's a great privilege to share her with you for a couple of minutes.
So this little piece is dedicated by students who are missing me because I'm kind of. So I started the Makerspace 4 years ago, and I just kind of wanted to create it. I was like, well, why not? So you just put something on voters' shoes, and I got a table, and I brought in a bunch of stuff that I have in my house. And it's turned into this. It was, I started thinking it was just going to be at lunch a couple of days a week. It turned out that that wasn't going to be feasible because our school has different schedules at lunch, and they all wanted to be there all the time. So I'm like, okay, every day. It's very self-directed. I was very specific that I wanted it to be along the lines of tinkering, a drop-in. It wasn't something they had to schedule. It wasn't something they had to sign up for. It wasn't something that they had to pay for. But I wanted them to be making something, which includes, it doesn't have to be physical, but it includes programming, whatever. They have to be actively involved in something like that. So the only things they can't do really is play games on the computer or browse the internet or look at pictures of Beyonce, which I love. So it's worked. I will have up to, this is a picture of this year, just a few weeks ago. It's ranges. It's interesting when there's about 20 kids there. The kids will look around and say like, wow, it's so light today. There's hardly any people here. I've had up to 70. I do on a regular basis. They come in, they run in. There's some parents that have said, you've saved my kid's life because they have a place to go. But I think more importantly too, that they really are doing some amazing stuff. And they were doing such amazing stuff, and I was so impressed that I wanted to bring that into my regular classes. And I was hired to teach computers at the computer school. As Gary mentioned, there weren't a lot of people teaching computers there. So I had a computer class, so I taught programming and stuff. Wanted to revamp that to be able to include physical computing, physical making, and makerspace type activities. So I got a bunch more tables and pushed the computers aside, and I have, well, this is, so this is an example of in makerspace, but the idea that they would just as they basically come up with their own ideas through just the fact that they're working with their friends. So they created a scratch game here, and then just to sort of show, and this is all them. I was not involved in any of this. I walk up and I'm like, wow, that's pretty amazing. But this ended up being sort of the result, and this is just them who had never touched any of these things before, coming up with like the idea that they had this data one, and it's written on their data, the cardboard one, and then they 3D printed it, and so it's kind of, they do amazing things that I'm sure that in any school, teachers would be would be so pleased to see these kind of outcomes. So fast forward to STEAM Lab, where I do teach 300 students twice a week, 45 minutes, and I do have a defined curriculum. But in that defined curriculum, I wanted to bring that idea, like there was materials, there was process, there was still that social and the sharing portion, and feedback, and that they would be able to kind of combine the idea of being behind a computer, which is kind of a little, old-fashioned these days, with small computers and embedded computers and things like that. Physical objects. So, as I said, I have a syllabus that I kind of go to. They're doing biobots right now, biologically inspired robots. And one of the things that I love about my students is you give them a prompt. In this case, they're creating basic mechanisms as a study and exploration of how animal movement or animals move and what we can do to create our robots. And they all come up, this is like one prompt, but you can see like there's all sorts of things. There's a crank there, there's a belt mechanism, she's holding a joint mechanism, a part of it, there's this joint mechanism, that's a number of straws that represent the fingers. And here was another set from the circuits. They had to build a circuit last year, and again, you can just see from the range that these are all ideas that they came up with. They didn't have like a list to choose from. So I think the successes are what the students are able to do, and the fact that they can explore so many different things. And they have a lot of fun, and so do I.
Okay, thank you very much. So I think we have time for two more questions.
Really briefly, Tracy, in your slides you have regular and then closest to objects italicized. So that seems really easy. Can you talk about that?
Because they're quotes. Although I didn't do it, pattern, etc. So just the idea that I'm always thinking about all these ideas and sort of more theoretical things, but they always, sort of think and expect that those things should be able to be embedded into the actual work that's going on and what's happening in the room.
I want to address the question to all of you, and it's just very interesting. Oh, sorry, I didn't. So I also facilitate lots of like making workshops, and one of my main problems is that how do kids come up with a meaningful project by themselves? And because I found that lots of kids who did not have the meaningful project to start with tend to be distracted and not come to doing the difference.
I guess for me, a meaningful project is sort of driven by their own interest. If we're making biobots, that was my idea, but I can't imagine kids who couldn't think of some kind of animal they would want to bring to life. And so allowing them to have like a huge range in, as Amy talked about in hers, like you're guiding the kids, you're asking them questions, you're getting them to ask questions, you're giving them places where they can do some research, you're inspiring them with different things. So I guess with all of that, they're able to choose something.
To sort of brainstorming session, when we'd already taken them through some exploratory, whether it's with circuits or solo circuits, and Hummingbird, we've shown them things that they can do programming from scratch, where they've seen projects as they go, and they might remember this. We take them through a little bit of a brainstorming and throwing ideas, and they're much similar to what we do with CMK. But for the informal part in ours, there'll be times for 2 weeks I'll just lay out certain, like the little bits, they're just out, and we doing some projects in terms of inch-worn races and draw lots, things like that are going on right now. But those materials are sort of drive that, and they come up with their other ideas based on them. So I sort of see that.
Sorry, last question is
Why are we rushing to Kool-Aid? I'm just wondering why we're rushing to cover the water.
Everybody else goes over.
I'm just wondering about this. You know, 3/4 of the people up here, with all due respect, paved their own way to come and share their stories. Why are we rushing to have cordial? I don't understand.
I'd like to just ask one question.
Please.
It's been a magnificent presentation, thank you all. I'd like to ask, you're coming from very different places. I know you're all from the United States, but you've gone to Hong Kong, so I think you said that you can do what you wanted to do in New York, and you're from Los Angeles in a private school, and you're from school wherever.
New York State, sorry.
New York State, thank you. So, but you've got the same ambition, and I'd like Gary to. I'd like to just say one thing that's your major challenge in achieving your ambition, because I suspect they might be different because of your different circumstances. And some of you got a really good sample. You've got the same ambition, same constructionist ideas, but you've chosen to work in different places, and you're all doing wonderful things. So just one thing that's your major obstacle, and how you're overcoming it, because it will help us all. Thank you.
My battle in my school is a bloated curriculum. The number one thing our teachers say, there's no time. I can't get to that. I see what you're saying, but I can't. And I think that's the number one thing. To go out and going, you can throw out 50% of the curriculum, any 50%. It doesn't matter.
Right.
Oh, that was yours. I apologize. That was your quote.
I think I'll probably say it too.
Well, Brian, I apologize. I will now continuously attribute that to you.
Second grade to fourth grade because they really can't handle the math. That's an issue. So that's a pretty big challenge for us. I would say that's probably my biggest.
My challenge is I'm in the United States in a public school where the focus is test scores, teacher evaluation, the Danielson rubric, and my stuff doesn't fit into that. And I have that luxury because I go somewhere else and do it because I want to do what I do. The other teachers don't. But you know, I think the kids demonstrate what's happening. I've noticed that since I've been doing this. I mean, I have some fantastic supporters at the school that's why I'm here. So we do not take a week off as a public school teacher. The kids, the other teachers are amazed. They're starting to see these incredible things. Whether that is going to be able to happen in their roots, but you know, seeing is believing.
Gary.
No, okay. I'm on a profession that's had the art of teaching removed from it, and all that's been left is curriculum delivery and animal control. And so a lot of the themes that are coming up throughout this conference are just because folks don't know about teaching. They don't know about centers, they don't know about working with materials, they don't know about projects, they don't know how to identify what's happening inside a kid's head. They don't know how to have a conversation with a child without a script. And the people who are imposing this on us see the results getting worse and worse, whether you believe that or not. And then they make it worse by removing more agencies of teachers. So I think one of the challenges is granting a great deal more agency to teachers. And I think all three of them here represent that. You know, it's just, there wouldn't be many teachers in New York City who get to go to Pi, get to go to college. And she's here on her dime because she likes to share, likes to learn, and she takes her kids everywhere she possibly can. She creates opportunities for them that wouldn't exist otherwise. And we have this fact, I mean, she literally fundraised to buy a plastic table. So those of us who know better need to do better. Right? You know, I know I'll attribute this quote, as my friend Jonathan Posel says, you're only 7 once. And we can't have the smallest increment of change in schools be, the smallest increment of time be a year or a decade, or in some of our cases, 4 decades. There needs to be a sense of urgency. And I think that with the tools and the energy that are being brought to us by the maker movement and by microcontrollers and wearable computing, I think this is our last shot at progressive education. I think the future viability. I mean, I'll say one more thing. I was at an early childhood conference in the United States a couple months ago, and it's the best of times and the worst of times. 50% of the folks at the National Early Childhood Conference want to build a Reggio-like environment. They're constructionists. They dream of doing what we're talking about. The other 50% are concerned with how to teach 3-year-olds to manage their behavior. And there is nothing in the middle. And we're going to have a new kind of educational part about it that's going to be lovely schools for those who have means and obedient schools for everyone else.
We've had that for years.
Well, but it's occasionally a blend.
Get out of the United
There's
States.
such a shocking difference between independent schools and